Good afternoon, and thank you for joining us. Welcome to AWS 2017 reInvent Las Vegas. We are proud to present our two speakers today, Jagin Sundar with WANdisco and Rashim Gupta with AWS. Please give them a warm welcome.
Thank you, folks, for coming to our talk. My name is Jagin Sundar. I'm CTO at WANdisco, and I have with me Rashim Gupta of AWS, who is product manager for the AWS Snowball. Today, we're going to talk about Fusion for Snowball, which is a strongly consistent replication system that enables you to create hybrid cloud environments without any downtime. So what is WANdisco Fusion? Fusion is a replication system that enables you to create strong, consistent replicas of your data across wide area networks. You can make the replica between big data systems like Hadoop and cloud object stores and so on. The real value of such a system is that you can create a hybrid cloud environment in which writes are allowed on all data centers. That's an important distinction from simple disaster recovery solutions. In addition to this, we have the ability for you to convert your existing simple single data center on-premise Hadoop or other big data systems, even on-premise cloud object stores, into a hybrid system that includes a replica in the cloud. This can be done with no downtime at all. In addition to all of this, we integrate with AWS Snowball and Snowball Edge such that you can use these clever devices for your initial bulk load of data. Let me hand over to Rashim so that he can give us an introduction to the Snowball device, and we'll go into the details of the use of the Snowball.
Thanks, Jagin. So, hi everybody. My name is Rashim Gupta. I'm a product manager here in the Snowball team. So let's start by looking at the different Snowball services we have here at AWS. We launched Snowball, the first Snowball device, at reInvent 2015, so about 2 years ago, and followed it up with Snowball Edge at reInvent 2016. One of the primary reasons we released Snowball was a request from customers to make data migration patterns much easier. Before Snowball, the only way to import data was either over the wire or using disks. And there are a lot of use cases where sending disks requires a lot of work on our customers. They have to, firstly, it doesn't hold a lot of data. They have to encrypt it. They have to package it. So there's a lot of possibility for the disks to be damaged even before they reach AWS. And that's why we decided to release Snowball. So let's do a quick deep dive on each of the two devices to see how this makes data migration easy. So like I said, our first device was AWS Snowball device, launched at reInvent 2015. It solved a lot of problems that customers faced in data migration using disk. For example, it has a rugged impact case, which is both rust and dust resistant. So you order Snowball from us, and you don't have to package anything. We send you in a case which is very strong and resistant. And once you get the device, you hook it up to your network. Using the high network connections we have, you can just load the device quickly. Any byte that's written on the device is encrypted using our 256-bit encryption. And so whether you encrypt or not, we will encrypt it further. So when you send it back, even if someone gets a hold of the device, they cannot really decrypt your data. Finally, we have an e-ink label on the device itself, which is a Kindle, which has a UPS shipping label. But the key part about this e-ink label is it's cryptologically tied to your account. So once we receive it, as soon as we scan it, the data is guaranteed to end up in your account. So there's no, again, we're just making sure your data is secure all the way through. Once we released this device back in 2015, a lot of customers had the need for doing pre-processing. And so we followed it up in 2016 with Snowball Edge, which is quite similar to Snowball, but it has 100 TB of storage, but it adds a compute chip in the device itself. So this opens up a lot of edge computing use cases because customers can now do pre-processing on the device itself. Also, because we have a compute chip, there is the device can expose itself as an NFS interface, so you can mount it like a drive. It also has an S3 compatible endpoint. And this is very powerful because now you can actually point your S3 applications and use the same S3 SDK against the device instead of the cloud. So even if you don't have connection to AWS, this can act like a mini S3 in your on-premises with limited subset of functionality. The compute chip can run AWS Lambda, and this device can also be clustered across many nodes for durable storage. Some other features that Snowball devices have is you can do both import and export data out of AWS. We have an SDK which you can actually integrate with for ordering better with your pipelines, so to make it automated. You can import HDFS data. Both the devices are HIPAA eligible, and like I mentioned before, everything that's written on the device is encrypted. So that's a good overview of Snowball. I'll give it back to you.
Thanks, Rishi. All right, let's clearly state the use case that we're addressing here and how our technology is going to solve the problem. Assume here that you have an on-premise big data or object store system that you're using for several uses. Ingesting data, running analytics on it. It could be Hadoop-based, it could be Cassandra, whatever. Your business requirement is to create a replica of the data in the cloud and run a true hybrid environment. The note here that I'd like to make is that when I say true hybrid, I mean you should have the ability to write into both your cloud replica and your on-premise replica. And our technology is the only way that you can do it today. Now, once you create your hybrid environment, you want to be able to run analytics of different workload sizes in both those data centers. The challenge here is your on-premise system is a live cluster. It's got data that's flowing in constantly. It's got analytics that are running. You cannot take downtime. How do you manage to do this migration and creation of the hybrid cloud? A naive approach would be to order a Snowball, load the data onto your Snowball, and ship it off. But there's a problem here. Once you ship the data, if you continue to write to your on-premise storage, you don't know what changed since the data was shipped to Amazon. Essentially, when the data lands in the Amazon cloud bucket, it's already out of date, and you have no idea how to reconcile the changes. This is what we call the on-premise live data problem. You've got to stop ingest at this point. Considering that you've invested a lot of money in your on-premise big data system, it's unlikely that that's feasible. Enter WANdisco Fusion. Here's how you'd operate it. Towards the end of this presentation, I'll go into the details of the technology we use, but basically you install a Fusion server as a proxy both in front of your on-premise storage and your Snowball. Once you install it, it proxies all the writes to the underlying storage system. The next thing that happens is that you run a repair, so all of the data that's not in the Snowball gets copied to it. As you're copying your data, the Fusion system is continuing to build a log of changes. It's using an algorithm called the Paxos algorithm to coordinate changes that are made. I'll tell you what Paxos is later. It's very clever in that it lets you write to both sides of your quorum. Once it starts accepting these changes and makes a log of changes, you are now free to ship off your Snowball, and you don't need to take a downtime at that point. You ship off your Snowball, the Fusion server attached to your on-premise storage continues to create or keep the log of changes. Let's say it takes 4 days, 5 days, perhaps a week for the data to arrive in Amazon's data centers and to get loaded onto Amazon's bucket. At that point, we reincarnate the Fusion server attached to the Snowball up in the cloud. It retains its state, comes back, connects with the Fusion server attached to your on-premise storage, realizes that it's fallen behind by some hundreds of thousands of transactions or write activity, and starts catching up on those. It replays every modification made to your on-premise storage till it's caught up fully. Once the data has been gathered in the cloud, the Fusion server is now available for write both in the cloud and on-premise. You have created a true hybrid cloud compute environment without any downtime to your overall system. I'd like to finish this talk with a little bit more detail on our Paxos implementation. So what is Paxos? Paxos is this algorithm that a gentleman named Leslie Lamport came up with in late 70s, early 80s for consensus between multiple nodes in a distributed computing system. The challenges that these nodes faced were networks would go down, the systems may go down and come back, and we still want to achieve consensus. What is consensus? Consensus is the action where all of these servers accept a certain result. In order for you to create a consistent replica, you need to be able to make sure all of these servers make the same changes in the same sequence. These changes are marked transaction IDs here. In the first example, let's say server B or data center B makes a proposal. You have a majority quorum that need to accept the change. Once the majority of them agree, it's applied as transaction 170. Let's say, for example, that data center A goes down. B and C still form a majority, so they continue to make changes, and you have proposals 171, so on and so forth. Many transactions get accepted. Let's say A comes back. The network connectivity is restored. It is now able to gather all the changes that were made and catch up to 173. At that point, it's now fully caught up and in a position to offer service. Despite having WAN link outages and server downtime, we managed to create a strong, consistent replica. Now, this process of catching up on a number of logged events, this is what I alluded to earlier when we talked about shipping off the Snowball, waiting for a week for the data to show up, and then gathering all the changes and applying them to that. So I'd like to end my talk at this point and open it up for questions regarding any of the technologies we've talked about.